Hey everyone, it's Mike from Arnold Tutoring. We have a past Math 1505 exam problem here, so let's read it. A bacteria population is modeled by the function n of t equals 10,000 times 8 plus t times e to the negative 0.1 t. When is the population maximized? So this is a good question because it actually looks like it's going to be a log or natural logarithm question, because you see a population that is modeled and it's increasing or decreasing or whatever it is, and generally we have to find the rate and then plug things back in for the time, and we use logarithms for that. But it's actually disguised as one of those. What this really is an optimization question. How do we know that? It says, when is the population maximized? As soon as we see maximized or fastest or slowest or minimized, we know it's an optimization problem, which means we're going to have to find the first derivative, set it equal to 0, and solve for the time, because it says when. We're going to have to solve for that time, or t, when the first derivative is 0. So let's figure out how we're going to find the first derivative. So n prime of t. First of all, let's look at the function as 10,000 times 8 plus t times e to the negative 0.1 t. So I'm going to say this I'm going to break this into three parts. This 10,000, that's just a constant, so we can leave that until the very end. It doesn't matter because the derivative of a constant is 0. The next part is 8 plus t. It's in a bracket, so that kind of goes together, and there's a t in there, so that is a function that we will have to differentiate. And the last function is e times e to the power of negative 0.1 t. Also, there's also a t there, and we can't multiply it into this bracket, or we don't want to. We can just go ahead and use the product rule. So because these are two functions with a t in them multiplied together, we're going to use the product rule. Okay? So I'm going to say n prime of t equals, I'm going to put the 10,000 at the very front, and then we'll do the product rule inside a big bracket. So the product rule says the derivative of the first times the second. So my first term is 8 plus t. The derivative of that is just 1 times the second. So we just rewrite the second term, which is e to the negative 0.1 t, plus the derivative of the second term. So the derivative of e to the negative 0.1 t, we just, any exponential function, we just rewrite it times by the derivative of what's inside. In this case, that's negative 0.1. By what's inside, I mean the derivative of the exponent. We're still in the product rule here, so it said plus the derivative of the second times the first as is, which is 8 plus t. Don't forget that part. Again, the kind of rule for the product rule, derivative of the first times the second plus the derivative of the second times the first. If we can keep repeating that in our heads, we won't kind of get lost in the question. Now we know we want to set this first derivative to 0. So I'm going to say, instead of n prime t, we're going to say it equals 10,000. Now I'm going to look to factor, because it's very difficult to determine what value for t will make this whole thing 0 unless we're in factored form. So the first step is you look for a common factor. Well, here's my first term, here's my second term. I can see that there's an e to the negative 0.1 t in each one. So I'm going to factor e to the negative 0.1 t out. And what are we left with? When we take it out of the first term, we're left with 1. Take it out of the second term, we're left with negative 0.1 into 8 plus t. Now, we can get rid of the 10,000, because if we just divided each side by 10,000, divided by 10,000, the left side is still 0. So that's gone. Now we have 0 equals e to the negative 0.1 t, bracket. If we simplify this bracket, we get 1 minus 0.1 times 8 is negative 0.8. So that's going to be 1 minus 0.8 minus 0.1 t. Don't forget to bring your minus through the bracket. So 1 minus 0.8 is 0.2 minus 0.1 t. And this is sort of our final spot. Now we look, again, factored form really helps because we have one term multiplied to another term. As opposed to before, we had a couple different terms in our bracket. It was really difficult to, again, just pick out that t value that will work. the important thing with the exponential function here, so we can deal with this first one, when we're in factored form, we can just take each term, so negative 0.1t, that first term, and set it equal to 0. Well, the exponential function, if we knew what it looked like, we know that this can never be 0. There's no value for t that you can put into this exponent that will make the whole thing 0. So there's no solution with this part. Then we just go to so this bracket must be equal to 0. So 0.2 minus 0.1t equals 0. And if you solve for t, it's going to be 0.2 equals 0.1t divided by 0.1. So you get t equals 2. So that means 2 seconds or 2 years or whatever t was measured in the problem, and it probably stated that somewhere in the problem. I just didn't write it here to save room. But at t equals 2, we know that the population is maximized. Now, a good question would be, prove that it's a maximum and not a minimum. So how do we do that again? We would do the first derivative test. I'll do that. I'll erase, and then we can show how we're going to do that. Okay, now we've got a bit more room. So we said we solve for t equals 2, which, again, trying to keep in mind what we actually just did, we said that when t equals 2, the first derivative equals 0. That's what we found. So, but the one thing we do know about the first derivative is that when it equals 0, the value for x, or t in this case, is either produces a minimum or a maximum. So how do we know that this is a maximum? We can do the first derivative test. So I'm going to put the spot where that we found where the first derivative is 0. So first derivative here. Now we just want to see if it's negative or positive on either side. So I'm going to plug in a different number for t. Let's say I plug in 1. If you plug in 1 into the first derivative here, you'll get 0.2 minus 0.1 in the bracket, which is positive. E to the anything is always positive, even though it's a negative exponent. So this is a positive times a positive, which is a positive. If you plug in 3, let's say, I'm just picking that number, it's got to be any number greater than 2. This bracket now becomes negative. E to the something is still positive, so this will be negative. So it shows that the function goes from increasing to 2 to decreasing, because remember we said that if the first derivative is positive, the function, or f of x, is increasing. Vice versa, when the first derivative is negative, the function is decreasing. The fact that it goes from increasing to decreasing at 2 means this must be a maximum. So we've used the first derivative test to prove that we have a maximum population at time 2. Hopefully this is helpful. You can always email us with any questions. info@arnoldtutoring.com. Best of luck on your exam studying. Thanks.